Hi, hello, this is your Lucky Sir. Group 13 elements, Class 7, P block elements, Group 13, Group 14 are in P block of Class 11. We'll discuss few objective questions related to them. General introduction and properties. In this assignment, we have actually 64 questions. If possible, all 64 in a stretch, otherwise 30-30. Okay, 30 to 32 like that. The order of abundance of third A group elements are boron, aluminium, gallium, indium, thallium. Aluminium is the third most abundant element in the earth crust. So aluminium is most abundant. Metals point of view number one. So here the right option is gallium, indium, thallium occur in traces in dash ores, sulfide ores, GaSins type. Okay, na gallium sulfide, indium sulfide, thallium sulfide. Gallium plus 3, sulfide minus 2. Okay, na so Ga2S3 type. Third A group element which forms only covalent compounds either in anhydrous state or in, so generally that credit goes to boron because boron is non-metal. Non-metals form covalent compounds. Which of the following is the most abundant in the earth crust? That credit goes to Mr. Aluminium, which is not a mineral of aluminium. Bauxite is Al2O3 2H2O. Corundum is just Al2O3. It is Al2O3 1H2O. So anhydride is calcium sulfate. That's your answer. The atomic radius of which element is least? Down the group atomic radius increases, so boron is least. Plus 1 oxidation state is for thallium inert pair effect. Thallium plus 1 is more stable than plus 3. The element that exhibits negative oxidation state is boron because boron is a non-metal. Among the third A group elements, the difference in the atomic radius is large in between aluminium and boron because boron to aluminium sudden increase is there. Aluminium exhibits diagonal relationship with beryllium. Beryllium of second A group element, third A group elements, aluminium. These will be having a diagonal relation. Which element cannot form a cation? Obviously boron. Non-metals cannot form cations. Electronic structure acquired by compounds of third A group elements in bonding is. Third A group elements will be having 3 electrons of them and 3 electrons they are going to get more. So total number of electrons will become 6. So that is called sextet configuration. Doublet means 2 electrons, octet means 8 electrons, superoctet means more than 8 electrons, sextet means 6 electrons. The nature of B2O3 is boron is non-metal, so B2O3 must be acidic. It is anhydride of H3BO3. H3BO3 is boric acid anhydride. Coming to the 14th question. Thallus chloride is more stable than thallic chloride. Thallus means plus 1 oxidation state. Thallic means plus 3 oxidation state. You can say inert pair effect. Which of the following pair of elements have same atomic radius? Down the group generally atomic radius increases, but because of sudden entry of the D elements, D block elements, or you say D orbital elements, when D electrons are present in the D orbital staining effect is very low. Because of that, there is no much difference in between aluminium and gallium. Thallium shows different oxidation states because, again, same problem. Thallium means inert pair effect. Blindly you should go. That is plus 1 plus 3. Thallium shows plus 3 with fluorine. Thallium shows plus 1 with chlorine like that. Which of the following is used in high temperature thermometer? That is gallium because of high liquid range. High liquid range element is in thermometers it is used gallium. At room temperature gallium is liquid. You can remember this point also. AlCl3 is anhydrous and covalent. Which one is a non-metal in group 13? Boron. So the advantage of solving these questions is you will be getting repeatedly same points. So these won't go from your mind for a long time. That's why try to solve these kind of questions. For inorganic chemistry, this is best. And if you are able to solve questions of NCERT last page, and if you are able to make notes of NCERT, that's a wonderful job. Which undergoes sublimation at ordinary pressures? We are discussing about sublimation. Sublimation means directly converting into vapor from solid state, that is done by boron. Boron liberates hydrogen gas with NaOH. This is boron is non-metal, so reacts with sodium hydroxide base and liberates hydrogen gas. The following compound is used in control rods of for regulating chain reactions. That means in nuclear reactors, that job is done by boron carbides, Bc3. The hardest compound of boron is boron carbides are very hard. Okay, now B4C3, Bc3 type of compounds are very hard. Coming to 24th question. Which of the following electropositive metal is used for the isolation of boron from B2O3? That means that must be highly electropositive, and that job is done by magnesium. This is not An, this is aluminum. Okay, sorry. Boron exhibits diagonal relationship with boron with silicon. Boron of third group, silicon of fourth group. Moissan boron is, this is somewhat memory type. Now I think we don't find in NCERT book. You can remember this. 95 to 98% is pure amorphous form. Borax, boric acid, boron hydrate. These are very important because every line is present in NCERT and you must be very aware of this. When boron is reacted with concentrated sulfuric acid, the gaseous product formed is SO2. Okay, now from H2SO4 you are getting SO2. In the preparation of diboron from BCl3 and hydrogen, the catalyst used is, okay, now generally we use copper and aluminum catalyst. Borax glass is a mixture of, it is NaBO2 and B2O3. The HPH bridged angle in diboron is, it will be like this. This is banana bond. These two are called banana bonds or tau bonds. And asking HBH bond angle. So this bond angle is asking. The bond angle is 97 degrees. Memory. Don't worry about this question. 31st question. Borax when dissolved in water exhibits alkaline nature because Na2B4O7 is made up of strong base and weak acid because of this B4O7 hydrolysis. Anionic hydrolysis, you can say. And next coming you will get this question also. Alkaline hydrolysis, alkaline nature because of anionic hydrolysis. Shall we go continuously? I think we can, right? 32nd question. On strong heating, boric acid gives B2O3. Boric acid, as I told you, H3BO3. If you are heating this, first it forms HbO2, further it forms B2O3. HbO2 is metaboric acid. Okay, glassy BD is obtained by heating. Okay, Na2B4O7 you can comfortably heat and you can get, from this you will be getting the glassy bead. On heating this, Na2O plus B2O3, which is used for borax bead test, is not given by, borax bead test is given by transition metals. So you can say aluminum is best option. It is not a transition metal. Boric acid is prepared from borax by the action of boric acid from borax. Just add acid type of things, that is enough. Okay, Na2B4O7 plus HCl if you are adding, it will be forming 2 NaCl plus H2B4O7, which further gives H3BO3, boric acid. 36. The number of atoms involved in bridged bonds in one diboron molecule is, bridge bond means one boron, one hydrogen, one boron. This is bridge bond. So here total number of atoms if he is asking, it will be like this. Okay, now boron, hydrogen, so 4, because 3 option is not here. The bonds not present in diborane are BB bond is not there. Okay, now BHB bonds are there. Bridges direct, there is no BB bond. Which of the following does not react with diborane? Diborane is very reactive because diborane is electron deficient actually. So diborane reacts with chlorine, reacts with bromine, reacts with water, but no reaction with iodine. Diborane reacts with carbon monoxide to form B2H6 BH3CO or B2H62CO. Anything is fine. You can mention like this. It is an addition compound type. Diborane on hydrolysis gives definitely H3BO3 because diborane is B2H6. On adding water, it turns into boric acid. The number of bridge hydrogen atoms in diborane. Bridge hydrogen atoms are two. One is above the case, one is above, and one is below. The formula of kernite or razorite is Na2B4O7 4H2O. The following has a potential to be used as rocket fuel. So rocket fuel B2H6 diborane, when it is burnt in oxygen, it forms B2O3. Along with that, it releases 1976 kilojoules per mole. How can I remember? Very simple. This is my birth year. Okay. In diborane, the hybridization of boron is diborane. The hybridization of boron is sp3. I read somewhere in book that mostly it is sp3. Okay, mostly it is sp3. So if that type of word is also there, don't worry. Diborane means sp3. The number of 3-centered 2 electron bonds present in diborane. The number of this is 1, this is 2. So it is 2. Reduction of BCl3 with lithium aluminum hydride gives BCl3 reduction with lithium aluminum hydride gives B2H6. Okay, so it is diborane. Basicity of H3BO3 is, it is very interesting. Actually, it is monobasic acid, but it is not a proton donor. H3BO3 not a proton donor. It won't give any proton of its own, but it reacts with water and forms BOH4 minus and releases proton. That's why it is called monobasic. It is releasing proton not of its own. It is releasing proton of water. It is actually Lewis acid. It can accept electron pair. And basicity point of view, if you see, it can release one proton from water. Okay, now one interesting point it is. Coming to question number 48 about aluminium. Aluminium becomes passive with concentrated HNO3 because of the formation of oxide layer Al2O3. The gas liberated when aluminium reacts with concentrated sulfuric acid. Concentrated sulfuric acid with metal, you can expect sulfur dioxide. The alloy used for making coins, aluminium copper, it's called aluminium bronze. Which metal forms a protective oxide layer to prevent corrosion? Aluminium. Just now we were discussing about this with concentrated nitric acid. Or in general, Al2O3 layer is formed on this, which protects the metal. Diaspore. Corundum, diaspore, bauxite and gibbsite. This is corundum, this is diaspore, this is bauxite. Bauxite is not there, this is gibbsite. If 2 is there, this is bauxite. So the answer is this. This is corundum, this is diaspore. Sorry, answer is this one. The impurity in white bauxite is, white bauxite contains silica as impurity, SiO2. Red bauxite contains Fe2O3. This is in red bauxite. In metallurgy, the substance which can act as deoxidizer is, deoxidizer means which can remove oxygen. So that job is fantastic done by aluminium because aluminium loves to be with oxygen. Okay, now when aluminium can comfortably with oxygen, so it is deoxidizer. Okay, dihydrate of alumina is called, dihydrate of alumina means Al2O3. Al2O3 is called bauxite. Okay, now dihydrate means Al2O3 2H2. As I told you just now, dihydrate means 2 water molecules. Regarding aluminium, the wrong statement is, guess what is the wrong statement regarding aluminium? It becomes with HCl is wrong. With HNO3, if it is there, then that is correct. The remaining options are right. Assertion. Aluminum liberates hydrogen gas with both NaOH and HCl. Right assertion. Aluminum is amphoteric metal. This is also right and correct explanation too. So coming to common atom is potash atom, K2SO4, Al2, SO4 taken place 24 water molecules. Aqueous solution of alum is, you see this one, it is strong acid, strong base salt. It is strong acid, but this is weak base. Weak base is strong acid means definitely it undergoes cationic hydrolysis. Cationic hydrolysis is acidic in nature. All alums, okay, now all alums contain same number of water molecules actually. So have similar crystal structure, that is called isomorphous, you can say. Alum is used as styptic, antiseptic, mordant, all. Okay, now styptic means to stop bleeding. As antiseptic also it is used. Mordant, mordant means color fixing agent. In that way also we can use. Gibbsite and corundum respectively are. Gibbsite means, as we were discussing, corundum is only Al2O3, only Al2O3 option is here. So you need to go with this one only. 64 questions we have completed in a row. Wonderful job, guys. The chemical composition of cryolite is Na3AlF6 cryolite. Okay, now. Which of the following are the uses of borax? Generally, in this kind of questions, all options will be there. Okay, now, as a flux in metallurgy, in making Pyrex glass, in leather industry for cleaning, as a preservative. All done. Thank you. Signing off, Lucky Sir. If you like, your job is to like, share with your friends because sharing is caring. Okay. Thank you. Namaste.